Good afternoon, guys. My name is Wilson Chua, and my presentation is at the intersection of data analytics, cybersecurity, and AI. So, without further ado, we recall that a few days ago, the DICT did say that their websites were under attack by 1.4 million. I think it's in a day, right? So as cybersecurity defenders and blue team operators, how would it benefit us if I tell you or I share with you an idea that can help reduce 60 to 70% of your workload? 60 to 70%. So what we found is that we can actually block 60 to 70% of the attacks at the edge. 60 to 70. But a nice thing was, as of yesterday, we were able to block 90%. So on a good day, we can block as much as 90%. So going back to the DICT example, how many people do you need to do forensics on 1.4 million attacks? Versus how many people would you need to do forensics on like 140,000 attacks if you were able to reduce it by 90%. And so the rest of the talk will be sharing about how we did it and why it's possible. So here, that chart shows you that in this particular day, we were able to block 60% of the attacks. The blue portion is the one that was not listed in our blacklist. Moving a bit backwards, a blacklist is something that we implement on firewalls and on routers. So if we see an IP that is blocked, it won't get anywhere further. It will never reach your servers. So it will be blocked at the edge. So that's what we talk about when we discuss blacklist. That's the basic idea. And consider this. On the screen right now, you see the very famous 7-stage of cyber kill chain. And if we are fortunate enough to have blocked the IPs used by the hackers to attack your network, you will realize that we are in effect able to block all the 7 stages of the cyber kill chain. For example, in number 1, our blacklist includes very well-known IPs from Shodan, Sensis, Binary Edge, and all those quote and unquote research institution that probe your network and then publish all the weaknesses that are then in turn used by hackers to discover your vulnerabilities. So at day 1, if all of these IPs are blocked, your network is essentially invisible to most of the hackers. Also, even if the hackers were able to get in and install their malware, guess what? That malware has to connect to a C2 system. And we have a 60 to 70% chance of blocking that C2 connection because their IPs are well known, and it's part of our smart blacklist. That goes well also the same for phishing links, malware. They can't really do harm if they can never enter your network. And that's some of the beauty of a smart blacklist. So all of those. But there's a intrinsic weakness in using smart blacklist. Let me ask the audience here, how many of you have implemented blacklist in your network? Can we see? Okay, so those of you that implemented blacklist, you will undoubtedly know this issue. We now have 4 million, but as of that writing, there were 3 million known bad IPs. If you were to load 3 million IP addresses into your firewall, guess what happens to your firewall? It breaks the firewall. Therefore, not only is it expensive if you were to pay the subscription, because there are commercial services that lets you subscribe to their bad IP list. What we did was we used open source bad IP, collected them, and then rated them using AI and machine learning to figure out a smaller size to compact it. So basic firewalls will crumble under a 3 million IP block. Now, further context, this morning, DICT Secretary Aguda did mention that, let's help the government secure the internet space in the Philippines. You will see here an analysis we made using shadow servers data. I attended one of Barry White's talk in Singapore, where he mentioned that, a lot of MikroTiks and Fortinet are already exposed online and most likely have already been backdoored by state-sponsored actor. Now, in the Philippines, Indonesia, MikroTik by far is the majority of exposed firewalls in the country. And because they're the majority exposed, they are more than likely to be backdoored. In case of some civil war or whatever, you will expect state actors to activate all these backdoors. Okay, so that's the takeaway. The problem with those firewalls is that they are basic firewalls. They are not the high-end Juniper, Cisco, what else? Checkpoint, Sophos, that are really rated to handle a lot more blacklists. These are basic blacklists. And so our goal here is, can we reduce 3 million bad IPs into something less than 70K? And we did. But now, as of this writing, it's now 4 million bad IPs that we are able to reduce to 80K. And still block 60 to 70%. Now, here is our workflow for our machine learning project. We wrote the paper. It's being submitted. I'm not sure if it will be published or not. So that's the paper. We're using XGBoost. And that's the output. So those of you that have machine learning background, this is what we call a confusion matrix. And so the upper left is the true positives. The lower right are the true negatives. And the diagonal like that are the false negatives or false positives. You will notice that the machine learning model was able to predict a majority of the cases. In this case, the question was, put up a model that can predict the top 70K IP that will block the majority of attacks next week, based on the attacks you received this week. And so it was able to do that very, very well. Now, the reason for that, and so we were wondering, how come we're using only 70K out of 3 million bad IPs, and we're still able to block 60 to 70%? Apparently, when we looked at the data and did a little bit of digging, you will see a Pareto principle in effect. So this is a histogram. On the x-axis is the number of times we saw this IP attacking our client's network, the number of times. So you will see that the majority, 1.6 million IP, never hit any of our networks. That's the large bar over there. The second large one hit our network only once in 7 days. So we're figuring out, we don't need these IPs. we can concentrate on the high volume IPs at the extreme right. Does that make sense? And then going forward to what we call explainable AI, what was the basis for the model to do the prediction? And apparently, the number one predictor of whether or not an IP that is hitting you this week will still hit you next week in higher volume is what we call the number of incidents. If an IP hits your network more than 10,000 times this week, chances are high that they will still keep on hitting you next week. Does that make sense? Okay. The other predictor would be the number of IPs that are being attacked by a single source IP. And so you can see that by far, the IPs that attack a lot of destination IPs are more than likely to continue attacking your network in the next 7 days. Does that make sense? Yeah? Then we look at the number of ports that are being attacked. By far again, the IPs that are pasaway. What's pasaway in English? Aggressive IPs also were seen to be attacking not only a lot of IPs, but also a lot of ports. So in a sense, they're trying to do a brute force reconnaissance of your network to see the open ports. And that is why they account for a majority of the attacks on your network. Now, from a defender's point of view, if I can block and drop them at the edge, I just need to send abuse email and do not need to do further investigation. It's a lot less work for us if we can block them on the first stage of the the cyber kill chain. Does that make sense? Okay. And so the next question here is, if we load, how does it compare if you load, let's say, 200,000 IP versus the 70K IP? And you will see here, this is the before and after. Before we optimized it, this is the CPU cycle of our firewall. You will see that at times it will reach 60–70%. And that is not good because the user, particularly those that are playing time-sensitive game like, online games, they will complain about latency. The moment your firewall reaches that CPU utilization, you will start getting complaints. But what we did was we loaded the optimized, smaller, very compact, less than 2% of the 3 million. Tama ba? On about 2.5% of the 3 million IP. 2.5% results in a very low CPU utilization. And remind you, at the 2.5% of the total bad IP volume, we are still able to block 60–70%. And what I did was I reached out to my friends in the industry because I don't have a micro tick. Remember the earlier chart that shows the majority of firewalls in the Philippines is a micro tick brand because they're low cost. So we used an RB3011. And we wanted to figure out if we were to load the 70,000 IP, would it kill the switch? Because it's a low-end firewall. Sorry, hindi pala switch. Low-end firewall. Will it kill it? So immediately, as soon as the blacklist was activated, boom, all of these attacks suddenly became visible. Whereas before, there was no blacklist, the users never even knew attacks were coming in. Now, this is what we noticed. There was a spike on the CPU at the instance that we were loading the scripts. Because in MikroTik, you do not just load or ingest the CSV. You have to load a series of commands like insert this IP into this table. And so what we did was we created a script to spit out the ready prepared script. So you only have to load the script and run execute. When it is executing, the CPU will shoot up to 70%. But after the script is run, it will go back down. And J.R. Valdivia noticed that there was no difference in CPU operations before and after loading the script. Next, you can see here that part of this, one of those IP showed up in CrowdSec as being malicious. And so you can see very aggressive, which really opened up their eyes to the fact that there are a lot of attacks coming into your network. If you are not loading smart blacklist, those attacks will hit your servers. But having the smart blacklist, at least 60 to 70%, and in good days, 80 to 90% of all the attacks hitting your network will be dropped at the edge. And that's a huge win for network defenders like us. What JR did was he also ran a buffer bloat test on the MikroTik RB3011 to see the added CPU cycles. And even with the script, it got an A+ rating. And notice the usage, 124 Mbps at the time. So next, we also went into Fortinet. That's the #2 most exposed firewall in the Philippines. And we work with a company, one of Fortinet's distributor in the Philippines called uas.com.ph. Okay? And almost immediately, it spit out all of these IPs that were attacking that particular network. And if you take a look at this, you will see that there are no false positives. True positives lahat yan. Now, what we did privately is to open up those pre-formatted lists on GitHub. Free to use. I would be happy if you were like to provide feedback of, oh, okay, you missed this IP, or this IP is a false positive IP. Help us make it better. So we have ready-made list. So all you have to do is download and run. You don't even have to insert the IP, for 70,000, it's not feasible to manually do it. So we have already pre-made MikroTik, Fortinet, and even pfSense. Every Sunday, that list gets updated. Every 7 days. So every 7 days, that's it. And that's me. And that's the end of my presentation. Questions? Sir. DNS.
Cloud platforms such as AWS. So were they tested there, or were they only tested on consumer IPs?
So a bit more detail about our process. We'll be very open. We get the list from several sources. Abuse IPDB, Virus Total, APNIC, Snort, Scenes, Stamp. We get it from a lot. And we have algorithms to try to figure out, okay, if this IP is listed in 2 or more blacklists, chances are it cannot be a false positive. right? So, but because we worked with JR, in the early days, pumalpak kami. Because we made mistakes. Some of the Google IPs were included. So the JR's client complained, oh, hindi kami makapag-Google. So we looked at it, oh, how come this was? So that was the early days. So we fixed that. But having said that, you are right. Because we are seeing a trend where hackers actually prefer Microsoft, Azure, Google, Cloudflare IPs to attack you. And so sometimes when we see those owners of those IP, we tend to do a double check. And so that is where the community comes in. This is public service. We're not charging for it. And so if you use it, all we ask is give us feedback. Help us make it better for the rest of the community. Help us help the microtics and the Fortinets in the Philippines, in Asia, become more secure. Like just yesterday morning, when we saw the stats, port 8728 saw a spike. And those of you that manages microtik routers know that that is a brute force port used by hackers to invade microtik. I hope I answered your question. Doon sa DNS DGA domain question, we have another paper coming out. Given an IP, how do you know if it's malicious or not? That is the question. Yan. So there's a lot of algorithms going inside there. Yeah. Yeah. Thank you for the question. Any other question? Sir Regan. Yeah.
Yeah, again, thanks for the wonderful presentation, sir. How does their model actually handle at day zero if an attacker actually is not yet part of the blacklist, right? So if he's using an unidentified or a new IP address, so how would your model actually handle that?
Very good question. There is a 60 to 70% chance that we will block it because hackers never attack from their own IP. They have to use a compromised IP somewhere out there, right? And chances are, if that compromised IP is already blacklisted, even if they have a 0-day, as long as you drop them at the edge, you are in effect protecting yourself partially from 0-day. Partially. You cannot claim 100%. At least, 60 to 70%. So that the rest of your team can now focus on the remaining 20 to 30% of the attacks that do get in.
So just follow up, sir. So would your team then investigate further after that to whitelist it possibly?
Yes, so what we do is a triage of sorts. So we look at what ports are more sensitive. So the common sensitive ports are 22, 23, 21, 3389, 3306, 1433. These are the common ports that if they breach it, they have a higher chance of owning your server. So those are the ones that we focus on. And then the rest is, okay, which are the higher volume attackers that were not listed, right? Should we then add them to our updated list? So that's the next question.
Yeah, thanks, sir. Sorry, sir. Are we talking about IPv4 only or IPv6 as well?
Excellent question. We're talking about IPv4 only. Okay? IPv6 is trillions of IP. And I cannot block the /32/64s. Yeah?
Thank you, sir.
Sir.
this is two-part. The first one is more of a feedback, sort of,
Sige
but
po.
slash question.
Welcome ang feedback.
And nice. So based on the data analytics that you perform, do you think separating what are the compromised IPs against those attacker IPs will be helpful in somewhat, improving, because you will be able to know which are the IPs being used by the attackers. Because coming from the context of your answer to Sir's question a while ago, there are IPs that are compromised, so they can also be used for lateral movement or other further attacks.
Do you mean internal IPs or are you meaning external attackers IP?
Well, I think for this case, it's both, because the attackers are from the outside and the ones that are compromised are in the inside.
So I can share a best practice that we do internally. We foresee that it's only a matter of time before one of your internal users get hacked, get compromised, gets a malware installed. So what we do to counter that is to look at DNS logs, and that's where your question of DGA. So we're developing the routine so that if we see, so we collect DNS logs, we monitor, we classify it. Right now it's a crude system, but eventually when our algorithm is developed, fully developed, that should be automated as well. So the idea is, let's say your user, one of your users gets infected, it will start to do a lot of DNS queries. So either it will do a DNS query for the C2 domain, or it will do a DGA domain query and do an NX domain query. So those are two things. A third would be that your internal user uses DNS to extract the data out. You will never see it because you don't normally monitor DNS traffic. So those are from the internal. From the external side, most of the blacklisted IPs are compromised. Most because we know, because we write. If one of the hackers attack us from one IP, that gets recorded, and our system will automatically send an abuse email without fail, an abuse email to the owner of that said IP. And we usually get back a reply that, oh, thank you, I didn't know, this was just freshly formatted. I never expected it to be compromised, but we will take care of it.
Okay.
Yeah.
Thanks. I'll ask my question maybe offline.
Sure. Hopefully there are more questions there. Last 2 minutes or last 2 questions? Last 2 questions. Eduardo. Hello. So, Pakitry nyo when you get back, the links are there, try loading it. And the feedback to me was, ang daming files. The tip here is you look for the most recent one. So you can see the week by week. You will see it's a weekly file, so you look for the most recent weeks. How many of you are planning to resurrect your smart blocking after the talk? How many of you haven't been blocking, but maybe it's time to revisit? No? Show of hands? Nothing? No one? Sir, question?
Yes, sir. Sorry. Habol lang. Question. So the tool or the algorithm is focused on having an IP put into the blacklist. How about if the IP has done its due diligence, cleaned its systems of the attacker, how fast would the algorithm
7
detect
days.
that and revert that from black to to the whitelist?
That's a very excellent question. So what if your IP is compromised? It gets added to the blacklist and it is used by hundreds of MikroTiks and Fortinet, then your server effectively becomes null routed, right? So the question here is, how long does it stay? The default would be every 7 days. As we update, if your IP is not attacking anymore, we don't see any activity, the algorithm will automatically downgrade that IP, and so it will not get to be the top 80K of the IP. However, because we're friends, if you feel that, okay, this IP has been cleaned and I cannot wait for the next 7 days, just give me a call, we'll look at it, and if it's warranted, take it out. Diba? It's like a spam house, right? You can email them and they'll unblock your IP. Yeah. So similar to that. So thank you for the question. I think we're running out of time. Thank you for attending. Hopefully you can help spread the word.